In example 7, we're going to be asked to find a quartic function. It's a word that's not used terribly often, but whenever we talk about the idea of a quartic function, what we're referring to is a polynomial of degree 4. So this would be something of the form ax to the 4th power plus bx to the 3rd power plus cx squared plus dx plus e. This same pattern that we've used for our previous polynomials, though, runs us into a little bit of an issue in the fact that we can't use e as a constant. The reason being that e is a specific mathematical constant. It's approximately equal to, I should say, not exactly equal to, approximately equal to 2.718. If you've never encountered this constant e before, it's not too different from the idea of pi being approximately 3.14. It's just a value that is set aside and reserved as a mathematical constant. We'll talk about it a little bit later in this course. What we'll need to do then is just use any different letter besides e, say f, something else, as that final constant. In part A, we're told we want to let x equal the number of years since 1990, meaning again, we'll have to adjust our values for our years. Following this ongoing pattern until finally 2009 would be equal to 19. We can enter that information in Desmos, just as we did with the previous examples, and what we should be able to arrive at would be a model equal to negative 0.0005 x to the 4th plus 0.02 x cubed minus 0.2244 x squared plus 0.344x plus 9.8335. Again, as long as you input something of this form as that model that we want to construct, making sure not to use e, Desmos should kick out each of those different values for the coefficients for you. And then we're asked in part B, what does the model estimate for the homicide rate in 2014? So this would correspond to a value of x equals 14. I'm sorry, since this is year since 1990, that would correspond to x equals 24, which means we would want to take that value of x equals 24 and substitute it into our model. Substituting 24 into our model will actually give us, in this case, a result of approximately 0.573, or I'm sorry, negative 0.573, which, if we're thinking about the context of these values, should lead to a little bit of confusion as to what this value would actually represent. So our model is estimating the homicide rate for a given year, and it's outputting a negative value. The best way I could think to interpret that would mean that people are actually somehow being brought back to life through the opposite of homicide, which isn't a thing that exists. So in this case, while we're able to construct a mathematical model for this data, now we're looking at a prediction for the year 2014, which was outside the original data set, and this value doesn't make sense, meaning that as we try to make these predictions outside of our data values, we have a model that, while it is a good fit for the data, isn't a good fit practically for the situation that we're trying to understand or model in this scenario.